Good afternoon, everybody. My name is Marc from the Catalan Bioenergy Cluster. This is our first meeting together with the Derby cluster, which is on the other side of the border in France. In this case, we decided that it would be interesting to meet some project experiences according to our companies. And excuse me, there is some. Okay. So the idea on this workshop will be to show from our partners, our companies, how are they developing projects here in Catalonia, but also in Occitania, in France. And then we will have some time to discuss together at the end, okay? First of all, we are going to make a short, brief presentation of both clusters, so you will be better know about our activity, and that's it, okay? I will start. Our cluster in Catalonia is one of the latest one who arrived in Catalonia. Catalonia is one of the regions in Europe with more clusters. There are over 24 clusters, and in this sense, we have nearly 7 years of history, and we are already the cluster most specialized in bioenergy in South Europe. Our value chain, it's quite singular because we should engage partners that could make production and distribution of bioenergy from all different types of biomass, from forests, from agricultural biomass, from waste management companies. Then we have companies specialized in manufacturing, installation of the maintenance of equipment, engineering and energy services companies. And also we have a strong commitment of public administrations to develop the bioenergy market, because it's one of the energies that we have, and it's one of the most important resources in our case. Since last year, we have a new board of directors with the idea to make a representative of the different segments of our value chain here in Catalonia, from building sector, from energy companies, from research centers. And the idea is that from our point of view, the scope of the energy sector in Catalonia is that we have to make the most efficient management of biomass. In this case, we have an advantage competitive product, which is forest biomass. We are the third European country with more forest biomass resources. Then we have also a strong potential developing agricultural biomass, because Spain is one of the regions with more oil industry or wine industry and fruit industry, and all the products related to these agricultural products could become biomass to be used. Also, we have a strong industrial park in Catalonia, which generates a lot of sludge and all other byproducts related from these industries. And why not? Catalonia is also known because we are one of the most important pig factories of Europe. So we have a strong and an important manure and a slurry production here in Catalonia. Okay. Last 10 years, most of the projects has been already done related to make projects related to biomass, from boilers, heaters, and district heatings. And some projects related to gasification and pyrolysis are starting to attend and to be built in Catalonia, from the demonstrative plants to become industrial projects. And the biogas production is still very few development in this case in Catalonia. I will show you some of the examples of these installations that are already in Catalonia, and one of them also that are being the first ones to be biomethane injection on the current network of natural gas. Okay. Also, we have a strong opportunity to use biomass and the resources to make other products, byproducts, no? And how we could use it for making use instead of using plastics as biopolymers or as other types of biofertilizers that, as you know, this industry are paying energy. The cost of energy is very high at this moment. Okay, in Europe is the main renewable energy consumed at this moment with 11% of the gross final consumption, and it's occupying 85% of the total thermal renewable energy in total. It's related to heat production. We are not talking about electricity, and has a huge impact in decarbonizing our continent. Also, what is important that the bioenergy industry in Europe is leading in technology, because we have over 74% of the global bioenergy suppliers are in Europe. And the situation of a scarcity of materials and other products or rare metals, for example, it's not affecting so much our industry. And also it's interesting in terms of job creation, because we need to use energies that helps to create jobs on the land, on the countryside. So we need to promote this energy in this case. Important to know that the bioenergy is our circular energy, and we have to promote as much as we can. And the bioeconomy is another step, no? How we could connect the productivity of the economic system to a more efficient management of the biological system in this case. In Catalonia, the biogas is awakening. We think that, well, in Europe, there are almost 20,000 biogas facilities. In Spain, it's like another planet. No, it's only 146 biogas facilities, which are spread within the agro-industrial sector as a sludge for water operators or for landfills, no? Also. And in Catalonia, we have only over 20 biogas facilities, and most of them are related to manure and the slurry management, and the traditional cogeneration plants with digesters or without digester, in this case, to promote the slurry management of the production. Okay.
Oui.
Apart from that, with the current resources, we know that Spain could be the third European country producing biomethane.
Tout à fait.
And we know that we could cover between 25 and 65% of the current natural gas demand.
Oui, c'est ça.
Countries,
oui.
There is some.
Oui, tout à fait.
Marc, we cannot hear you. Yes.
You are in mute. Are you here?
Yes.
Yeah.
Okay. So sorry, so as I was saying, biomethane production in Europe has a strong potential, especially in countries like France and Germany, but also in Spain. And according to our experts, with the current resources here in Spain, could be the third European country producing biomethane, and could cover between 25 and 65% of the current natural gas demand. We have some projects already injecting biomethane here in Catalonia, related to farms and landfills in this case, and there are someone nearly to inject, because are also managing the legal permits to do it. And this is the situation now. We hope that this year we will solve some issues here in Spain related to the biogas production and all the legal framework related. So we have a strong expectancy to develop the biogas market this year. That's it. I think that it's enough to have a short and brief presentation. And Sonya, the floor is yours.
Thanks. I will just share. Can you see it now? Yes, can you just confirm, Marc? Oui, c'est bon. Super.
Yes, Sonya, we see your screen.
Yeah, thank you so much. Thanks for being all here. Merci a nos intervenants. Gracias a nuestros vecinos en España. So just a reminder for all participants, the session is saved and the presentation of all attendees with contacts will be shared with you. So if you have any question, we have the chat, so you can just let it there and we will talk after together. So my name is Marc Sonya. As I said, I am project manager at Derby compétitivité cluster dedicated to energy transition. The cluster was created in 2005 and is part of 55 national clusters approved by the French state and one of the 5 national clusters dedicated to the energy transitions. It carries out its activities in the southern French Occitanie and Pyrenees Mediterranean region. We have 3 headquarters, one in Perpignan, one located in Toulouse and Montpellier. Our mission is developing innovation at regional, national, and international level. We want to accelerate the emergence and the marketing of innovative, as I said, in the international directives. And contributing to the strategic objectives of the Occitanie-Pyrénées-Méditerranée region by becoming a positive energy region. The technological, this is different from CBC because our technological focus of the Derby Center is structured about 5 areas, 3 principles, which are production of renewable energies adapted to the area, smart energy networks and energy efficiency and the new uses in and 2 other areas which are more transversal, which are numerical and digital and societal challenges and training. So today, the Derby competitiveness cluster, I will say just Derby to be more rapidly, counts 170 members, included companies, research centers, laboratories, universities, higher education establishments, and institutional partners and local authorities. We can see in this page that our members deal with all sectors of energy transition, and we can see that we have 68 of these members which are in bioenergy, of course without counting the companies known for the solar or storage or wind or other renewable energy, which also have projects in biogas or biomass. So to talk more about figures in France and more specifically in Occitanie, our region, first of all, I would like to share with you some of these figures about biogas and methanization in France. We have more than 1,030 biogas units with about 72% units of cogeneration and 28% units of injection. At the bottom left, we notice points of different colors on a map that define the different type of biogas units. You can notice that the color green is the most present, which represents 80% of biogas units are on farms in France. At the bottom right, we noticed that the increase in the number of sites in service in France. So now let's focus more in our region, Occitanie, which is near Catalonia. We can see that in 2021, more than 50 methanization units with biogas valorization. So you have points in the card, and for this one we will see that our region wants to respond to a repost strategy, which is which wants that our region aims at becoming a zero net energy by 2050. We can see that in 2050 we want to attend 239 methanization units, which is around 156 gigawatt-hour. Otherwise, to conclude, for this presentation, you can say that according to the figure at the end of 2020, our region Occitania produced around 53 gigawatt-hour per year, or around 2.5% of national production, and that the region was at the beginning the 11th of 20 in terms of biogas production. So it's not bad. Behind, we can see like a real positive dynamic and several projects that are being set up in this region. So for me, it's done. We can start with our attendees.
Okay, thank you very much, Sonia. Let's begin with the Catalan attendees.
Yes.
The first place we have Ester, Coma, which is the project manager of the PRIMA platform, which is a strategic project from the Catalan Energy Research Center. Ester, good afternoon. The floor is yours.
Good afternoon, and thank you for inviting us. Well, as Marc said, I work for the IREC, Institut for Energy Research of Catalonia, and today we are going to present the PRIMA platform, which is the PRIMA. Sorry, I haven't shared my screen. Let me see. I'm having some issues with my Teams. I hope it's not going to let me behind. Can you see now?
Yes.
Yeah, great.
Yes.
So yeah, we are going to present the PRIMA platform. It's the platform for the integration of renewable energies and energy storage. We're also going to explain a little bit about IREC, so you can know a bit more about the Institute and about our work in terms of research and collaboration in projects. And then we will focus on the PRIMA project, so you can know more about the project and see if we can find any partners, any future collaboration agreements after this meeting today. Sorry, I forgot to introduce my colleagues, Ramon Gené and Xavier Solà, who are also in the meeting today. In case we have to discuss any issues later, they are also in this meeting today. Next page. Now. So IREC is an institute for energy research. We belong to the network Recerca, which is the network of research centers in Catalonia. As Marc said, we collaborate with the cluster in the research of biomass and doing also some research proposals and collaborations together. And well, thank you, Marc, for inviting us as well. Regarding IREC, our mission is to generate scientific and technological knowledge in the energy field. Basically, we have to consider all the value chain and we have to promote the use of sustainable energy to achieve this energy transition that we are all trying to achieve through our countries. No? In terms of IREC, it's a public-private institution. We have the support from the Catalan government as well as the Spanish government and a few universities. And we also have, sorry. My sore throat is not very good. Sorry. And we also have, oh no, sorry. Hi. And we also have to, oh, my voice is gone. We also have to have a dual orientation. So we have to look at the research in terms of aspects looking at, oh no, wait a second.
Excuse me, do you mind that we maybe after the next panelist, it's better for you?
No, it's fine, Mark, I think.
Okay.
And perhaps Esther, if you want, I can try to go.
Let me try now. I think my voice is back. It's just that I have a sore throat.
A couple of slides and you are more quiet to follow.
Yes, Ramon.
It's up to you.
Yes, please.
Ramon, so if you mind.
So I think it's back now. Sorry, it's my sore throat. So in terms of research, we have to focus on the long-term research, developing products and technology on the energy field. We collaborate with different institutes around the country, and we also have a long-term commercial projection. In terms of the market orientation, we focus on the development of technologies, and all our research needs to end up in the market sector. So we need to develop the energy sector in the same fields of the lines actions established by IREC. In terms of Ramon, can you continue, please?
Okay, don't worry. I think that this dual perspective of IREC, it's also shown in the organization of different departments. We have 4 groups that it's what you may see in the left-hand side that are more focused on, let me say, research in more fundamental in materials for energy, and this means it's more in laboratory issues for small scale. And on the right hand side, it's the 3 units that are more close to market, as we mentioned before, and it's in the scale of, let's say, more engineering and more providing solutions to the market. So in perhaps, please, you may just go to the next slide.
Yeah, I think
yes, may follow. Yeah,
I think I'm able to follow now. I have been able to. Okay, thank you, Ramon. Regarding the laboratories that we have at IREC, we have always worked in the blocks that Ramon mentioned. We have many labs. Some of them are more focused on the materials and the components. So you can imagine chemical engineers or physical engineers working on the components and materials. We also have 2 labs which are closer to the market and to the test of technologies and systems. These are the SAIL lab based in Tarragona and the Smart Energy lab based in Barcelona. Those 2 labs, although they are very good for the validation and demonstration of some of these technologies and the integration of them as part of the system, they have some limitations. We have only so far been able to try and test technologies up to the TRL 6.7. So that means up to relevant environments, but not real environments. So back in 2019, the IREC proposed to the Catalan government the PRIMA platform, which aims to cope with the gap that so far we have had from IREC, which is this gap of the real environment and the validation of the technologies prior to their market release. So our aim in PRIMA and our objective from the near future will be to be able to validate and demonstrate technologies and to help and support the companies, especially the Catalan, Spanish companies, but also companies from Europe and abroad, to validate their technologies and to help them to develop them before these technologies are released to the market. This is a big challenge, we know that, and we also have well, we have to not only build this PRIMA platform, which it's going to take some time. Also, we need to make sure that all this is in line with the objectives of the energy transition and the National Integrated Energy and Climate Plan, as well as the National Recovery, Transformation and Resilience Plan. In PRIMA, we aim to build a new testing and demonstration platform in real environments, and we think that this is a very new thing that we propose, and this is what we are going to show you a little bit of our value proposition, what we think that it's the difference and makes the difference of our proposal. In terms of experience, we aim to capitalize on the experience that we have been achieving for the last 10 years in IREC, and we want to help to transfer this knowledge to the companies and the industry to make sure that we all help on this energy transition. We need to achieve these market TRL values, and that's why we think that through this PRIMA platform we will be able to do that. In terms of the integration, we offer a global and integrated vision of energy systems. As you may know, there are many research centers and platforms around Europe where you can see technologies or demonstration centers. Some of them focus on the hydrogen sector, some of them focus on the biomass sector, others in the biogas. But it's difficult to find a place or a platform where you can find different energy systems, different vectors, all in one space. And that's what we are trying to propose through the PRIMA platform, a place where the different energy systems and vectors will be able to be connected, integrated, and validated together. In terms of the projects, we would like to act as a lever for the development of research and development projects. We will try to promote collaboration within the companies in Catalonia and in Spain, not only through the agreements between them, but also in European projects and consortiums where we can participate, as well as help these companies to know about them and participate in them. In terms of the innovation, we aim to implement a regulatory sandbox. Some of you may know about this. It's quite a new thing in terms of the energy sector. It's a well-known thing in the business and finance sector, but it's not as new in the energy sector. We want to develop a sandbox within PRIMA where we can test and control and validate technologies or strategies of business models that, according to the current regulations, would not be able to be tested. And that's one of the other things that we propose. In terms of collaborations, we are going to promote the collaborative validation of the technologies and the systems. We will try always to involve the actors of all the value chain and also promote the 360 validation, which means that when, for example, a company will come to PRIMA to test and validate a PV panel, if the company accepts and wants to do that, we will also let this know to other companies, inverter companies, battery companies, so they can all do tests together and work in a collaborative way. And finally, the training, it's one of the things that we added at the end, but it's one of the requests from the companies that we have been meeting so far. There is a lack of supply chain, basically. We all know that we need to achieve this energy transition, but how we are going to do it, how the people, the installers, are going to be trained, how they will maintain and operate the different energy plants. This is a challenge, and we want to help them via offering them training and using our installations at PRIMA to develop this knowledge. So, well, so far this is our value proposition. It's still work in progress because PRIMA keeps evolving all the time. In terms of the benchmarks, we have done a study and analysis of the different centers and platforms that are around Europe and around Spain and Catalonia. We have the responsibility of using our funding, it's a public funding, in a wise way. We don't want to repeat things that have already been done. We don't want to build things that are not going to be useful for the companies and the and the energy transition, basically. So we want to learn what's been done, and not only to be different, but also to complement and to help each other. So far we have been analyzing many different research centers, and we would welcome any suggestion from the people that is today attending this meeting. If we don't know one of the centers, we would really like to know more about what you have in Occitania and in South France. Regarding the program, here you can see our conceptual design. As we said, we are trying to integrate many different vectors of energy, and this is what we are going to do inside the PRIMA platform. We are going to have different pilot plants. So far, we have the plans to build 5 different pilot plants, which will combine test benches and demonstrators on an industrial scale. And basically, among these 5 pilot plants, what we are trying to achieve is to cover all the different concepts that you can see in this slide. The storage in terms of electric storage and thermal storage, climate neutrality by developing technologies in the fields of decarbonization, removal of fossil fuels in thermal activities especially. That means more use of biomass, biogas and hydrogen. In terms of waste and bioenergy recovery, which is something that it's probably the topic more relevant for today's session. We are working to develop a bioenergy plan where we can deal with the energy recovery of organic waste from livestock, from agri-food industry, to increase the production of biogas, the quality of the biomethane, the biohydrogen, and different types of renewable gas, basically. Also here, I would like to mention that the fact that we have located our PRIMA platform in the countryside of Catalonia in Osona, I will show that later. It's going to help us a lot because it's an area where we have lots of waste. And although waste is always a problem, in our case, it's like gold, and we really want some waste around us so we can focus and have enough value for our bioenergy plan. In terms of sustainable mobility, anything related with electric vehicles, green hydrogen, biomethane, all focus on the mobility sector. Electrification and flexibility. Here we are going to focus basically on the integration of renewable energies on the grid, smart grids, prosumers and energy communities, the integration of batteries, car charging stations. So all these complexities of the future electric grids, that's what we are going to work through this pilot plan. And then we are also going to have some experimental fields outside where we can basically develop pilot plans outside the building. Sorry. And finally, renewable energy in terms of hybridization and integration of solutions on all the areas of renewable energy. Here I will show a video of the
3 minutes.
Okay, I will show just a quick video of the installation. We have just 2 slides to go. Oh, sorry, the video. This is what we. Sorry. So, as I said, we are planning to build the PRIMA platform in the center of Catalonia, in Osona, and it's going to have a building of about 3,000 square meters with an area of outside space of 12,000 square meters. We are planning to have lots of energy from renewables, so we can be as self-sufficient as possible and as energy positive as possible. We will have a space for the test of hydrogen systems, biogas, also different concepts of methanation and biomethane. Also inside, as you can see here on the left, we will have offices for companies and also offices to host people from other institutions abroad or also from PhD students. And basically, we hope that by offering this installation where different energy vectors can work together, we can push on this energy transition. I haven't mentioned it so far, but we also will have a hub for sustainable mobility, where we plan to install a hydrogen station, a biomethane station, as well as electric power charging stations, ultra rapid, by the way. And yeah, that's basically the PRIMA platform. You can know more about it on the website. I'm not going to extend on that because we don't have more time. Also, if we share the presentation later, you have the chance here to look a little bit about all the different facilities that we are planning to offer within PRIMA. You can read that in more detail. It's what I've been explaining in the video, but here you have a bit more time to read it and have a look. The different pilot plants that we will have, the bioenergy, the thermal integration, the solar integration and hybridization, flexibility and integration, and the hydrogen plant. All of them will have not only the inside space, the space inside the building, but they will also have some space outside to bring containers, lorry containers, and do the tests outside. And finally, to finish now, a bit of a roadmap so you can know where we are in the project, and hopefully we can collaborate in the future when PRIMA is ready. So far in 2021, we have developed the definition of the project brief, the agreements between the political institutions and IREC to get a place to go and a plot of land to build our building. At the moment, we are at the design stage, starting the tendering process, not only of the project, but also of the construction of the building. And we hope, our aim is that by the end of this year, we will have started the construction of the building. So by mid-2023, we have the building ready to start the operation of the PRIMA activity. We know that it's quite optimistic, and especially when you have tenders and public tenders, but we also know that the energy transition is essential, and we want to be ready for that. We will see if we can achieve our targets, but that's our aim. And before I finish, I would like to say that although PRIMA is not available as a place yet, IREC is welcome to collaborate with any of your institutions, and also we can start developing projects and consortiums together. So when PRIMA is ready, we have the projects, also the funding ready for it. And that's it. Thank you very much. And if you have any questions, I'm sure we can discuss that later. Thank you, Marc. And sorry if I had a bit more time than I should.
Don't worry, Esther. Thank you very much. As you have seen, this is one of the latest experiences of our main energy research centers here in Catalonia, with the aim to promote business creation, at the same time technology transfer and research development. Now is the turn of Envolta Energia. Envolta Energia is one of the engineering companies based in Catalonia, which is specialized in biomass, but also especially in biogas. So Marius, the floor is yours.
Hello, do you hear me?
Yes.
Hello, thank you all very much. Thank you, Esther. I hope to keep my voice clear.
Sorry.
I don't know if I will be able, because I have also a bit cold. So let's see. I have to show my screen. One moment. Sorry, I cannot here. Okay, you see my screen. So thanks everybody. I'm Marius Aguirre from Envolta Energy. Today I will introduce what is Envolta Energia and Envitec biogas. After I will go forward with the use of biomethane, why it is the greenest fuel solution in Europe. And then I'll present a case study, which is Envitec biogas building in Germany for the production of bio-LNG. At the end of the presentation, you can also see some of the references Envitec biogas has built in France, mostly last years. So Envolta Energia, it's an engineering company. We provide sustainable solutions through consulting and execution. Our customized solutions are based on high technology, mostly photovoltaic and bioenergies. And our added value is that we developed internationally projects for our international partners, but both we rely on them for the projects we develop here in the country. Our integral vision of a project we audit, give consulting, and then the development of any project in the renewable energies for both public and sector and private companies. And we also developed international projects. For photovoltaic installations, we built turnkey here nationally. And for the bioenergy plants, as I said before, we rely on our international partners. In the case of biogas, it is Envolta Biogas. Envolta Biogas, it's a leading company in Europe. It's the first supplier of turnkey projects in Europe. It covers the entire value chain of biogas, from development to the construction and even the operation of the plants. Envolta operates its own biogas plants, so this allows big investment on R&D to be more efficient in the gas production. The annual turnover of Envolta Biogas, it's 190 million euros. It has more than 500 employees with 16 subsidiaries around the world. I'd like to explain today what Envolta has done last years. A lot of plants in France, but also explain what is doing with the LNG, which is what I consider the shift paradigm of biogas in Europe. Internationally, Envolta built more than 700 plants. In France, there are 35 plants in operation, 9 plants under construction, and some more in the pipeline. So Envolta has participated in this big increase of biogas plants in France last years. Today, Envolta is shifting from the traditional biomethane plants to the bio-NGVs. Bio-NGVs, it's the use of natural gas for vehicles from biogas, biomethane. The application of bio-NGVs opens a big potential where it does not rely more about the what were the aidings from each country, and provides a global market. Envolta foresees a big demand on bio-NGVs. So bio-NGVs are mostly bio-CNG, which is bio-compressed natural gas, or bio-LNG, which is bio-liquefied natural gas. Envolta has pilot plants and operational plants both in bio-CNGs and bio-GNL. What is the difference? Bio-LNG has it's when you cool down the biomethane or the natural gas. So it has more density, it takes less storage space, and it is easy replacement for a conventional diesel motor. This makes a good choice, a good solution for long-haul truck companies and sea vessels. LNG can be also transported in tankers or in trucks around Europe. The difference with bio-CNG, it's easier to refuel in the stations and also needs lower investment costs. So both alternatives are very good. It depends on each project. Why we expect a big increase of bio-NGVs? From Renewable Energies 2 in the Renewable Energy Directive in Europe, which was approved in 2018, implements a uniform framework for renewable energies in whole Europe. It includes legally bindings on each country with targets of 32% increase of shared renewable energies, a reduction of greenhouse gases emissions from 14%, and requires advanced biofuel and biogas quota of minimum 3.5% in the transportation sector. Also, it brings a global system of computation for the CO2 certification of biofuels, which will be under guarantees of origin. Here you see a graph with emissions of GHG, greenhouse gas. We have on the left there are on the left there is the fuel diesel, which was 90 or which is 94%, 94 grams of CO2 each megajoule burned. In comparison, the conventional ethanol and biodiesels release 50 grams per megajoule. The biomethane we can produce mostly from waste or corn. It is also positive in terms of CO2 emissions, very low, but it's positive with 18 and 34 grams per megajoule. Compared to all of this, the biomethane produced and used in the transportation from manure and slurry, it is negative, it's minus 95. This is because using the biomethane from manure avoids emissions of natural spontaneous biomethane, which is a big greenhouse gas. So when we compare burning a megajoule of diesel equivalent with burning a megajoule from manure, it is a difference of 182 grams CO2 in terms of savings. You can imagine this is a big quantity. As I was saying also, it's not just about the gas emissions, but also the quota required on the transport sector. The RED II demands at least 3.5% of emissions or energy consumed in the transport sector must be from advanced biofuels, which is, for example, biomethane. In some countries, this is even higher. In Germany, this is a graph for Germany. This is 20%. Also, Germany requires a reduction of the traditional biofuels, which were biodiesel and ethanol. So you can imagine that the bio-LNG, bio-GNBs are really a good solution for heavy transport, which needs a quick solution. It is also a solution for sea transport and cruisers. It's a solution that is already available. It has a low cost of investment. It reduces a lot of other harmful gases from combustion, like sulfur oxides and nitrogen oxides, and reduce noise emissions. For transport and logistic companies, this means lowest cost with more sustainable transport. So the bioenergy goes through concept and the case study I bring here today. Envitec bought an oil plant that was already built by Envitec in 2010. In 2009, it was one of the biggest plants in Europe with electrical production in mind, and it's transforming it to produce LNG. The LNG will be produced not only in this plant, but in other plants of Germany, and it will be liquefied in this plant. With this liquefaction, the LNG will be transported to gas stations, and then the GHG quota will be traded. So this is the case study, bioenergy goes through. Built in 2009, it was producing 22 megawatt electrics with more than 25 digesters. As most of or many of the biogas plants in Germany, it was used mostly energy crops for it. As I presented before, now the interest is on producing biomethane from manure. So Envitec prepared all this plan in order to receive chicken dung instead of energy crops, and is doing this transition. The targets from 2022 will be producing 25 tons of LNG per day, and also is using the LCO2. This is the outgas you have once you upgrade the biogas. You have biomethane and you have CO2. So it will treat also the liquefied CO2. this is a flow chart of the gas treatment. So before it was about the CHPs. Now Envitec is building all the methane. Methane is the solution for biomethane upgrading. So most of the biogas will go through this methane to produce both LNG and CO2, keeping some part of the gas for the CHP for own consumption. This the plant is not a small plant. It was built having in mind models of biogas digesters, 5 biogas digesters with 1 intake tank for liquid manure, and this modular design was replicated 5 times. Also, there were the CHPs and the residue storage tanks. The extension of the plant plans in a building of more residue storage tanks, together with a biomethane liquefaction plant and the biomethane upgrading plant. So this is how will look the biomethane, the bio LNG plant.
Marius, it's time, 2 minutes to close.
Yeah. So it's over mostly. So bio GNBs are a real actual alternative to diesel. It's a solution we have today, and it's a solution that can represent a very big reduction of CO2 emissions. This is why we believe it will be strongly developed in the coming years in Europe. As I said, I live in the presentation, so we can share some of the references Envitec Biogas has built in France. Thank you very much, and I stay at your disposal for any question. Thanks.
Thank you very much, Marius. Interesting experience, how to transfer this experience in Spain and also in France with other projects, but also in PRIMA, why not, no? To promote a demonstrative plan together, no? Now it's a time from AERIS, the Tecnologias Ambientales, which is a small enterprise with a high research and innovation component. So the time is yours, Oscar. And just to remember that you can ask some questions on the chat, and then when we will finish all the panelists, we will ask all the questions and discuss together. Okay.
Thank you very much, Marc.
Good afternoon, Oscar.
Good evening, everyone. Can you hear me?
Yes.
Thank you very much. Am I sharing my screen? Can you see it?
Yes.
Very good. Okay, so yeah, like this. So good evening, everyone, and thank you very much for considering us for this event. It's I'm really grateful to CBC and Aguirre. It's really nice to have the chance to show you our solutions and to have also the chance to learn from all of you. What I would like to talk to you about today is our state-of-the-art technologies for biogas production and also for biogas desulfurization. I'm happy to see that my colleague Marc from Ecotech is here as well. So we are partners in some of the technologies I will show. So it's nice to see you all here, guys. So who we are, very briefly, AERIS is a spin-off of the Autonomous University of Barcelona. It's composed of 18 researchers, professors of the Autonomous University of Barcelona and the Polytechnical University of Catalonia as well. We have been awarded with a series of research awards since we are really active in R&D in different fields. And we've been in the market since 2009. So what we do in AERIS is we take all the knowledge that we develop in the laboratories of the UAB and of the UEPC, and we put them in the market. Okay, so we have a very important component of innovation and research, but we are also a business. So we want to sell and we want to have the best product we can. So in AERIS, we have participated in more than 50 publicly and privately funded research projects, but we also work at industrial scale in implementing all these solutions that we have. We work in the field of energy, both energy production and energy seizing, also air treatment, wastewater treatment and seizing as well, circular economy, and so on. So today, and in regards with these things we are discussing today, I would like to tell you about mostly two technologies that we have and that are deeply related with energy production and seizing. Number one would be our Hydrusa Hydro 1 technology, which aims to produce biogas directly from wastewater. And the second technology, which we commercialize in partnership with Ecotech, would be the biogas reactor for biogas desulfurization. So it's two different technologies, non-related to one another, but I believe that they fit quite well in today's session. So very briefly, I'm showing you the Hydrusa project. This is a publicly funded project from 2020. And it aims at developing innovative solutions that can cope with water scarcity in certain regions of the European Union. For example, in Mediterranean countries, in our eastern coast, for example, in Spain, we are suffering from water scarcity. We are aiming to find a solution for these problems within this project. So what we do here is to seize wastewater and rainwater and water vapor from air, some different water sources, and we try to produce something valuable out of them, like biogas or crops or different added value products. And also at the same time, we try to develop some, let's say, advanced and profitable business models that can give some richness locally to the places where these are implemented. Okay. So as you can see, the diagram of the project is quite complex, but I would like to focus your attention here. This is a UASB reactor, which has been designed and developed by AERIS and which aims at treating wastewater from the local town of Antissa in the Lesbos island in Greece. And currently this system is treating all the wastewater from this town and producing some valuable products. Let me show you. As I told you, this has been implemented in the wastewater treatment plant of Antissa in Lesbos, and it consists in a series of processes which turn wastewater into some valuable products. Okay, so first of all, we have this UASB, which is a kind of anaerobic digester, which treats wastewater and produces biogas and some other valuable compounds. Okay, so wastewater, this is the red arrow, goes out the UASB reactor partially treated. More than 70% of the solids and of the COD has been removed. Then it goes across some constructed wetlands in which the purification is completed. Then wastewater crosses some processes of filtration and disinfection. And finally, this now clean water is used for irrigation of crops. So, summarizing everything, we have sewage coming from a wastewater treatment plant, more than 10,000 cubic meters a year. All this water is treated in a series of UASB reactors, anaerobic reactors. So, in this, more than 70% of the organic matter and of the total solids are removed. Then these cross some constructed wetlands and are used for irrigation in crops. But also, and this is really interesting in the frame of this session, we're producing around 4 kilowatts hour every hour. This is around 100 kilowatts a day of biogas, which is then compressed and used to fuel a vehicle, which is then employed for publicitary purposes within the project. Also, a very small amount of sludge is produced and then used for composting, and then it goes again to the crops. So it's kind of circular, all that you are seeing. Okay, so from a technical point of view, you can see here the design of the UASB reactors. These are not so big, actually. Two reactors working in parallel, 23 cubic meters each, with base, square base, 2.5 meters each, and a height of 4 meters. And here you can see a drone picture of the actual plant working in Greece. So in the top left of the figure, you can see the two UASB reactors. In the bottom right, you can see this balloon here. This is the gas holder. So we can see the amount of biogas we are producing. It changes, of course, with seasons, but in summer season, we are producing around 30 cubic meters of biogas every day. And we are removing up to 50 kilograms of COD every day. So these are really, I believe, nice numbers. So this is a project, this is a system that has a very wide range of adaptation, and it can be used in many other circumstances. And this is something we're trying to achieve in AERIS. I pass to the other system I was telling you about, and this is a system which is used for biogas desulfurization. As you know, biogas contains a fairly important amount of H2S, hydrogen sulfide, which is very corrosive, harmful, and so on. And this concentration can reach up to 3%. This is 30,000 ppm. So you can imagine that this can lead to big problems in the engines, in the systems downstream, and so. So after many years of research at the Autonomous University of Barcelona, we came up with this design of a biological reactor which can cope with such high H2S concentrations. No? So very briefly, the system is composed of 3 different vessels: a chemical scrubber, in which gaseous H2S is transferred to a liquid phase, hence becoming liquid H2S. This H2S is then fed into a bioreactor in which it is biologically oxidized to an oxidized form as solid sulfur, sulfate, and so on. And then part of the solid which is being generated goes to a settler in which we can separate it and then further lead it to valorization. Okay, so let me show you what it looks like. In the left picture, you can see an actual debiox system, which is operating in southern Spain. In the right side, you can see the SCADA. Okay, so you can see more or less how everything is connected, it works, and control, and so on. And this particular system is aimed at treating around 200 cubic meters per hour of biogas, so it's not a really big flow. But as you can see, the concentration in H2S is really high. It's 2.2%, 22,000 ppm. So the removal efficiency of this system is really high, above 99.9%. We can see that the H2S outlet concentration is below 25 ppm. So this is a safe biogas for engines. So we are really, and the customer actually is really happy about this. For example, this is a very big plant working in Denmark right now. It has a biogas flow rate of 4,000 cubic meters per hour, with an H2S inlet concentration of 3,500 ppm, and as you can see, the H2S outlet concentration is below 100 ppm. So again, it's a pretty efficient and also cost-effective system. You can see some other debiox systems we have commercialized in partnership with Ecotec. So we have a few examples here in Spain, many of them actually in Scandinavia, and we have built some of these systems all around the world, Latin America, Africa as well. So we know the stuff. So let me show you just a few quick take-home ideas. AERIS can be a reliable partner for you in R&D activities, but also in industrial projects. We can design and we can implement systems for air treatment, biogas treatment and production, and water treatment. And especially, we're always open to collaborate in energy production and energy seizing related projects. So thank you very much, everyone. Merci beaucoup. And if you have any question, I'll be really happy to try to answer it. Thank you very much.
Thank you very much, Oscar. Excellent presentation within the time. This is the time of the cluster of the Derby. So it's your turn.
Yes, thank you. I just want to thank first speakers. It was really relevant for us to know how it works in Spain, which are news and projects in terms of bioenergy market. So thank you so much. I just want to remind you that we will devote a few minutes at the end of the presentation to a dialogue to respond of the questions we have. So don't hesitate to write your remarks and questions in the chat. So let's move to in the other side of the border. We start with Monsieur Sébastien Pommier, who is a PhD and researcher engineer in LINSA. He will present us the unique platform in region which offers various research and demonstration services, and which the following speaker from Terega is one of the stakeholders of this project. So, Monsieur Pommier, you can share your presentation. Thank you.
Thank you, Sonya. You hear me, everyone? It's okay?
Yes.
So, okay, so I
Yes,
just
perfectly.
share the screen. So, can you see everything clear and big?
Yes.
Thank you. Well, I will now, for a different type of presentation, I will maybe be closer to research, and I'll show you some of the what we can do to help companies developing their activities. We are located in Toulouse, and we are at INSA. This is an engineering school, and we are close to Toulouse Biotechnology Institute, which is a research lab. Well, the name of a kind of company, which is not company, because it's public, is CRIT GPTO. CRIT means Regional Center for Innovation and Technology Transfer, and GPTO means Chemical Engineering and Environmental Technologies. We are supported by the region, Occitanie, and we are member of different kind of innovation clusters. Especially, we try to have actions for the National Center for Biogas and Methanization. So first, well, this is the same scheme as we saw before. This is some everywhere we can help about dealing with wastewater treatment and energy production from agriculture, from industry, or for urban areas. And we have knowledge, and we can help for everything about bioprocessing of these waste and wastewaters for their valorization. We have three main competence, which are wastewater treatment and valorization, and energy production by biogas mainly, and also chemical production, because we can also build very interesting chemicals from the waste and wastewaters. And we have also special skills for interactions between physical, chemical, and biological activities, especially for cementous material. And we know a bit about sulfur cycle, so I was very interested by the last presentation. And we try to have experimental aspects for all of this, but also process modeling to help understand everything. And we have also a colleague that is specialized for helping for more global point of view with industrial chain modeling and all about the urban integration of the innovation. So what is our job is to answer questions. So we have different types of ways to answer questions. We can have lab experiments, data processing and modeling. We can perform laboratory experimental, and we try to make a scale up for some industrial pilots, and also we can help on on-site analysis for helping companies implementing something new or trying to answer a very annoying issue that is common, unfortunately. So we use laboratory tools for characterization of everything, for the flows, for the incoming matters, and for the gas and so on. We use modeling and simulation and experimental tools. So this is just to have it in mind. And I will talk about a bit more about the experimental pilots, because this is what the kind of pilots we generally have, and I think a lot of research centers have these types of pilots when they deal with biogas production and methane production. So we have different types. So this is what the previous presenter talks about UISB. This is what we have in the lab for this, with the granules inside. But we also have these ones for more solid matter. And everything we can do is try to make as much as information available as possible. So we monitor biogas and pH and temperature, and we can sample everything and to make more analysis. Sometimes simple bottles are very useful to understand and to answer questions also. But the point of my presentation is more to talk about a more ambitious project we have, which is called the platform Solidia. We have this project that is now ongoing for it's the second year of the since the real beginning of the project. Just for a short comment, it's a very bad idea to start a project within a pandemic followed by a war. So I think everyone has difficulties here. So we have difficulties to have this project going on, but we keep fighting, and we are pretty confident now. So for this project, we are also have a great support from the region, Occitanie, and we cooperate with two main companies that are Clairvert, that is biogas plant provided by Envitec Biogas, and with the company Terega, that is in charge of the grid, the main grid, the big grid. You will have a speech about Terega later, and they are a great support for this project, and they help us to make this what I will share to you now. So this is where we are. Toulouse is just on the other side of the Pyrenees, and I think I have this so you can visualize more where we are. So Toulouse is where the lab is, and the platform and the biogas plant we are dealing with is somewhere in the country, close Villefranche-de-Lauragais. And here is what it looks like. So we have here the Clairvert plant is dealing with all organic transformation of organic matter. There's some wood processing here, but the main projects, the main industrial devices are for composting, and there is a biogas plant with a 3 HP electricity production. What we have is we have connected this plant. Sorry, this is not what I wanted to do. I'm sorry for this. I go to the end. Okay. Oh, sorry. What we have in this plant, we have connected the biogas production to a new platform, well, the building of this new platform has just started last month, and we have to be able to deal with new services that we can provide. Everything about anaerobic digestion processes, digested valorization is already implemented in the platform, but what's new is the biogas valorization. The aim of the platform is to propose an intermediate scale between the pure laboratory pilot scale and the real world of industrial demonstration, because it's sometimes very difficult to go from 10 liters to 300 or 3,000 cubic meters. So we can provide this service, and we have the purpose of providing technical help for research and development, especially for scaling up the stuff. And we want to accompany, I'm not sure of this English word, I'm sorry, to help or to go with partners towards the industrialization of their solutions. And hopefully, we hope this will be a very interesting way to help training for the teaching and engineering schools. So the main target is something between TRL 5 and 7. This is for technology demonstration at semi-industrial level. So we try to have this industrial considerations about everything about regulation, safety, that will be proposed on the platform, not proposed, it's an obligation. So that will be proposed on the platform, but this is very helpful for the project holders also. And we will help them. Sometimes using a big scale is also interesting for even slow TRL, because sometimes you deal with heterogeneous systems and you cannot make simple experiments at the lab scale. So we have also some projects from low TRL. So from now we have existing, we have already dealt with some anaerobic digestion projects with French ADEME, the energy environment in France, about a special technology that's called leaching bed anaerobic digestion. We have also performed essays for projects about the durability of cement materials. And we also have projects with the digested fractionation in order to get the best of the digested to give it back to the soil, or making, why not, products, especially for nitrogen recovery. This is what we used to have. And now what we want to have, I'm sorry, because I don't have pictures of it, because it's ongoing project and it's in building process now. But I have the main ideas here. So we want to deal with a new biogas valorization facility for everything about gas epuration, gas enrichment. Epuration meaning removal of undesired compounds, that is CO2 or H2S, as previously mentioned. Enrichment, we have a lot of activities and a lot of demand for what we call methanation, that is a conversion of CO2 by the means of adding hydrogen from renewable electricity. And the platform can also be useful for everything about the control of the gas quality. So the idea is to develop what has been many times mentioned before, what can biomethane be useful for the energy systems, for the natural gas grid, or for biofuel. So we have connected this plant to the platform, and this is how things look like. We have here the gas coming from the Envitec biogas facility from the Clairvert plant. And this makes it possible for us to have about 40 normal cubic meters per hour with a classical biogas with 60% around of CH4. And then we will have a compression system, so we can have the distribution of this biogas for up to 10 bars for different pilots that can be accepted on the platform. So we can help companies to test their new technologies, to help them making essays, and to help them develop and go further for the next step to the market. What we have also is electrolysis here from electricity. So we can produce also H2 up to 10 normal cubic meters per hour. So we can also help around this, among these pilots, we can help the pilots that want to deal with methanation. So this is, well, of course, we have some place to stay to keep warm and dry. So this is what is going on. We have already 2 main projects about methanations that will be accepted on the platform. And I think we are open for every collaboration for the future. And hopefully this meeting is very interesting, because I think we have a lot to share. And now I will leave the floor to the colleagues of Trifila, I think. If you have questions, I can answer later.
Yes, thank you so much, Sébastien. It was very interesting and concise presentation about this project. We will move to the company Trifil that will be presented by Bruno Roussel et Étienne Cairel.
C'est bon. It's okay for you?
Yes.
Yes. Okay. Good evening, everybody. We are very happy to be able to discuss with you this afternoon. I would like to thank Derby team and Catalonia cluster for allowing us to connect. It's very interesting for us. Our presentation is built in 3 points. In first, a quick presentation of Trifil, our identity card. To second part, with presentation of her project called TH 2030 for Trifil Horizon 2030, which mobilizes us to develop our future industrial and financial model. And in conclusion, the presentation of her commitment to innovation. Research and innovation being at the heart of our policies since the creation of Trifil. Her TH 2030 project is only the result of this commitment. Trifil biogas production. Who is Trifil? Trifil is a public service created in 1999, and we are in charge of household waste treatment. Our action is based on pooling of equipment, cost equalism, and human and territorial solidarity, all in the territory of Trifil. We cover approximately 330,000 inhabitants on the southwest of France. We are east of Toulouse, completely the department of Tarn, and one part of department of Haute-Garonne, and one part of the department of Hérault. Also, we welcome and we treat 3 other clients, who approximately 375,000 people, and we treat a globality of more 700,000 people west. We are the Trifil activities is just the treatment. We are not in charge of the collect household waste. This is all the client who are in charge of the collect. And for us, we treat and we valorize all the waste. Approximately each year we treat 300,000 tons, and we have 2 sorts of treatment and valorization. In first, the material recovery. We have sorting and resolve, principally the recycled packaging and paper and the glass. And after, we have another part, the organics and other waste. And we want to optimize the energy recovery for this sort of waste. Etienne?
So our solution for waste treatment, for domestic waste treatment, if I accept all but is all plastic bags and all recyclable waste. So for the rest, we have a landfill, but we operate as a bioreactor. This landfill receives 200,000 tons per year of mainly domestic waste. And what we call a bioreactor is a special way of operating this landfill with three main characteristics. First, we work with quite small cells. We close each year a cell containing more or less 200,000 tons. We collect leachate, that's an obligation, but we inject this part of this leachate into the closed cell to enhance and to accelerate degradation and biogas production. And obviously, we collect biogas and we valorize it. So how do we valorize this biogas? The main plant is a CHP plant. You can see this on the photo. We have about 2,000 cubic meter of biogas, about 50% methane, and we generate more or less 3.66 megawatts at the moment. But this is for electricity, and heat is valorized in by heat by I guess we have a little network that contribute. But sorry for my hesitation. That bring the heat to our administrative buildings. We have a bigger plant, bigger issue in drying wood chips, as next to the plant, the biogas plant, we have a platform where we produce wood for. Well, I will explain. It's just a few slides after, and we implement an organic ranking cycle turbine to valorize the excess heat. So we produce a little bit more electricity with it. It's about 200 kilowatts. So at the same time, when we built the CHP plant, we decided to install a quite small biogas upgrading plants, which produce 30 cubic meters of bio-GNC. It's based on the PSA, pressure sewing adsorption process. So it's free of our trucks, or provided with this biomethane. And we had a pilot so since 2014 that demonstrated that it was possible to transform biogas into hydrogen by
vaporeformage.
Yes,
in French, vaporeformage.
Catalytic reforming. Sorry for my English. It's complicated. So instead of using methane, 100% methane, this was filled with biogas, raw biogas. Well, raw, no, it was filtered for H2S, but it was CH4 plus CO2. We have also, it's not really biogas, but we have so two platforms where we collect and centralize waste wood and other woods, and where we prepare wood energy like wood chips, and this is delivered to many heating units, and from we refill have 6 heat networks with central heating units that we operate ourselves. So we have photo on the right, where it's not a big plant, because we are not a very urban country, but it's a little city, and we hit 5 or or 6 public buildings in the city, for example.
Okay, for the project now, TH 2030, this is a global project with 4 axes. The first one is the waste prevention, with the objective to reduce waste production. We have the ambition to reduce 10% of waste production, with beginning in 2015 and object to 2025. Second axe is sorting of organic waste, and we would like, this is the French law, to extract the organic fraction from the trash. In third, extension of sorting instruction. We have one plant in La Bruyère near Castres. This is a new plant just to recycle all plastic packaging. And another plant in Blaye-les-Mines, we would like to prepare which different waste, where we would like to valorize all commerce. And in last, we develop the material on energy recovery with a new pole of new renewable energy here in the headquarters of Trifil, and with objective to valorize most of waste and also to reduce the stockage. We would like to reduce in proportion of 80% the present stockage. This is also a territorial project. We develop 3 industrial units in synergy. I saw one for the papers and packaging valorization center, one over for bulky waste preparation center, and the most important here, a waste sorting and recovery plant. And we are going to treat the residual waste, the organic waste, and different sorting error or refined bulky waste. And we produce, one is compost for, in fact, the agricultural, 2, the biogas, with production approximately of 700 meter cubes of gas, and the refuse derived fuel, a new energy for us, and we would like to develop a circular economy with one important plant, agricultural plant just in 2 kilometers of our plant. We are also work, I saw before, to reduce the household waste in a bioreactor, and to embarrassing these different products. We also reduce proportion of 23% greenhouse gas products, and in the same time we develop and multiply in 3 times the green energy. The injection of biomethane into the gas network, I said 700 meters cubes, and also we welcome another plant, a private company, CBC, in the place here, which will produce 300 meter cube. And we inject the gas on the Terrega the same company that we said before, directly direct injection. This production is approximately 10% of household gas needs in the territory, and we are waiting an annual revenue of 5 million in plain time. We have also contract with one company.
Just 2 minutes. Just 2 minutes.
Yeah. Okay. We have also invest on the refuse-derived fuels, about 41 tons produced, and we self-consumed in internal, particularly 16 tons, with output of 8 megawatts, and the 2/3 will be used local industry. Also, we produce hydrogen from the three fuel resource, the biogas or biomass, and we will organize the distribution station on the territory, probably 2 stations between 20 and 30 kilometers. In 1 minute, the innovation in Tréfil.
Okay, we just wanted to present you three research projects we are involved. Demeta, but Sébastien from INSA talked a little bit about it a few minutes ago. The idea is to develop biological methanation that would be more efficient than thermochemical methanation. The idea at the end could be to valorize the CO2 from the biogas into methane with injection of energy, of course. So, but it could, at the end, avoid the upgrading, classical upgrading units of biogas. I resume very quickly. We are involved in pyrogasification because we saw we had some waste wood, and not only clean waste wood, but also waste wood with paints and things like that. And on the ADF, we talked a little bit just before. So some tests are going to be developed this year on this type of waste, and this could join with the Meta project later. And to the end, we wanted to talk to you about a PhD thesis that we financed with IREC on dark fermentation. Well, I think I don't have time to explain, but the idea is to produce hydrogen from waste with a process that you can discover. And the first results we had show that this energy is not taken on biogas, but it's more energy than what we had on simple anaerobic digestion system. So I resumed.
Yes, just a picture of the future plant here in the Recerca, and it's the major units of Tréfil. Okay, thank you.
Thank you so much. When it's interesting, we don't count time, but thanks for this relevant presentation from Tréfil. So last but not least, to sum up, I give the floor to Paul and Lionel from Terega, which, as far as I see, they are already responding to the questions raised. So you can share your presentation. Thank you.
Okay, let me try to share my. How can I do that? It's okay?
Yes, you can put it.
Whoop, voilà.
How much time do we have?
15 minutes?
Okay, fine.
Okay, let's
Okay,
go.
so do you see my screen?
Yes.
Yeah.
Okay, thanks.
Okay, so after being mentioned by Solidia and Trifil, thanks for that. I will try to present to you who we are. So Energia is a French TSO, a gas TSO, transmission system operator of southwestern France. So the gas transportation is managed by two TSO in France, Recerca and Energia. And so to compare in Spain, the Spanish pending is Enagas. So here's some very quick key figures to describe more what we do, who we are. So we possess more than 5,000 kilometers of pipelines, which represent almost 16% of the French transmission gas grid in France. We also operate storage, so storage activity by processing two massive storage sites in our region. So our storage activity represents almost 26% of the French storage capacities, and it represents 1 year of gas consumption in our region too. So these storage capacities are strategic for France and Spain. So the turnover generated by our activity is around 460 million, and we are more than 660 employees. So that's the general figure of Energia. So here you can see the map of our networks in the southwest of France, from one side to the other of the Pyrenees. So the headquarters are in Pôle, and you can also see in the middle, in the junction of our two main networks, the two main pipelines, the storage dooms. So I'm not sure you can see, but on the map there are some green dots figuring the biomethane injection plants on a gas grid. So there are 3 today, and almost 4 or 5 GNC gas stations for mobility. So for us, the energy transition is a central topic, and it's also a part of our business strategy. So as we don't possess the molecules moving along our pipes, we tend to encourage the development of new gases to decarbonize what we are transporting, and to increase the development of these sectors. So we are very involved in, as you can see in this map, on biomethane, but also synthetic methane, NGV and bio-GNV, hydrogen, and sector coupling by multi-energy. But here, as I'm talking about biomethane, I will show you what we can do in Energia, and a different level of action we try to have an impact. So first, we have decided to develop a new business unit, biomethane and gas mobility business unit. So this, it's not the only one. With this, we have created 2 other business units, one on digital and one on hydrogen, made for multi-energy and digital. So the biomethane, the first things we've done was to try to participate on the scaling up of the biomethane sectors, taking part into and taking shares into 2 French biomethane startups, one called Dual Meta, and the other one is the Shadasek group. The first one, we tried to help them to develop their very innovating process and the very innovating location offers, which is very interesting for farmers. So the process is interesting because it mixes dry and wet inputs into the plants, and the location offer is very interesting because it offers biomethane plants for rent to the farmers. So it's quite innovative in France. And the second one is different. It's a more classical kind of biomethane station startup, but we try to help them to redefine their offers and to address better the market. But the biomethane and gas mobility business unit is also involved in NGV, and we try to deal with the Energy Public Union next to our headquarters to create new NGV station in our region. But it's quite tough for us as a TSO to be on the different parts of the value chain of energy because of the regulation, but maybe we can explain that points later. So that's what we've done into our very local level, but we are also involved in the national and European fields. So on the national field, here's the Comité stratégique de filière, nouveau système énergétique, so in English. In 2010 to develop the French industry sector. There are many different committees on automotive, aeronautics, aerospace, wood, chemical, food also, construction, but there is one on energy. And this one has been created in 2018, and we are a member of it since the year after, so 2019. And it gathering industries, trade unions, competitiveness cluster. I think Derby is part of it, and the ministers in charge of the topics. So this one on energy is divided into 12 different working groups on solar, wind, biogas, electricity networks, digital, cybersecurity, sector coupling, CCUS, industry, construction, hydrogen, and battery. So the one which is interesting for us is the working group on biogas. And this one is also divided into 6 working subgroups: industrialization, competitivity, positive externalities, innovation, and this subgroup is led by Terega, local content, funding, local appropriation, and this one is led by the French Gas Association. So the aim of the goal of this committee is to help structure the sector to reduce the cost of biogas. And we also did the same, almost the same at the EU level with what was created at the end of the last year, the EU Biomethane Initiative. So it was mainly launched by the Gas for Climate Association, in which Terega is a chairman. So the objective they fixed an objective of 350 terawatts per hour of biomethane injection for 2030, which is achievable according to us. And this position was welcomed by the Commissioner Kadri Simpson. So that's what we do in general aspect in the context to help to participate or to intend to participate to have an impact on the legislation, the reglementation, and the regulation of biomethane in France and for Terega precisely. So now I will let Lionel present you the translation, in fact, and the reality of what it looks like on the ground.
Okay, Paul, would you like to be my special assistant?
Yes, I will.
Okay, thank you. Okay, I'm Lionel, and I'm going to show you, to explain, and maybe to answer some questions with some slides, how biomethane developed itself in the past few years. And the first one, this one, yes. I'd like to put in light, or in perspective maybe, the green gas production with our objectives regarding carbon neutrality. This neutrality has been acted by law called the Loi Energie Climat, maybe in 2017 or 2015, I don't know exactly. And in order to reach our goals, the French government gave us some tools, some guidelines, and also some responsibilities. One of these tools is called the PPA, multi-year planning for energy, something like that, and imposes us to strongly decrease our consumption of fossil energies and increase the production of renewables in such a way that renewable gas represent 10% of our gas consumption by 2030. Today, among all the possibilities, only biomethane is a short-term answer from my point of view. So this slide, clockwise. During the first years, we had to evaluate all the potential that could be transformed biomethane, but also pyrogasification, power to gas. Then, thanks to a strong collaboration between the French government services, national agencies, DSO, TSO, and so on, an exhaustive framework has been built. So far, all the stakeholders know what input is authorized to be fermented, what are the conditions to be authorized to build a production plant, what are the conditions to be connected to the gas networks or electric networks, and most importantly, of course, what is the valorization mode. And today, France has chosen a feed-in tariff. Okay, so we can say that the present framework gave and still gives a good result. Last year, the French government made the feedback and considered that the original feed-in tariff was too generous, maybe too generous, and decided a huge decrease. And the effects were felt immediately, but the full impact will take place around 2024. And to be honest, if this feed-in tariff is less attractive, it is still attractive, okay? We are now in 2022, and the process is still ongoing. What we know is that biomethane and other green gas need some other tools to develop, market design mechanisms, for instance. And these are the topics that we are discussing today with all the stakeholders. Paul, next, please. On voit pas les graphes. Oh. Ah, magnifique. Okay, so now from a network point of view, this scheme has been modified and improved all over the years. It shows how to maximize the biogas potential injection, taking into account the present and the supposed future network capacities. First, we evaluate all the potential, and it is equal today to the third of the national gas consumption, biomethane only, of course, around 150 terawatt-hour, in line with the figure presented sooner by Marc, I guess. Then, to be efficient, France has been virtually split in 500 zones, taking into account, again, networks and the potential. Within a zone, DSO and TSO evaluate together the best infrastructure scheme, which is determined as the best combination between CapEx and inputs that can be valorized. When this scheme is selected by the network operators, it is presented to all the stakeholders, linked to that geographical zone. Remember, we are in France. There are a lot of stakeholders, municipalities, project owners, citizens, and so on. And when this consultation is done, the scheme is presented to the French regulator that analyzes all the benefits and, of course, all the costs. Then the Commission deliberates in favor of the solution. The project is officially declared. This is a long way to be officially declared. And then the connection study can be done. To answer a question from Luis, we are not obliged to connect a plant, whatever the cost is. That remains a decision from the producer. But in a way, we are obliged to do the study. Okay. Paul, next, please. Now, from the producer point of view, to be honest, producing biomethane is something very expensive. Okay. Here are some key figures. CapEx around 6 million euros for an average plant. Okay. OpEx 500,000 per year, including inputs, logistics, wages, utilities. You also need a large area around 20,000 square meters, which can be a huge difficulty, especially when land is expensive, which is probably the case in your beautiful country. One of the biggest difficulty also is the social acceptability. So a large number of consultation would be useful. This is time and this is money. Okay. Regarding the injection plant, this is really basic pipeway, an injection device, and you will face no difficulty to inject on DSO or TSO because of our large capacities. Okay, but if you decide to, or if you are allowed to inject on a TSO network, you will have to implement a compressor from on the producer side. Okay. So next, Paul, please.
2-3 minutes left.
Okay. Okay, it will be enough. What can a producer expect? That's the main question. The feed-in tariff, okay, has been built in order to ensure an internal rate of profitability close to, let's say, 10%. It was very attractive. This tariff is decreasing with the production capacity. Only the plants that are producing less than 25 gigawatt hour a year are now eligible to this tariff. It's very important to note. All the plants that are producing today are not concerned by this limitation. Okay, some of them are huge plants. We have here in Energia 2 plants connected or soon connected that can produce around 400 gigawatt hour a year. One of them is the biggest in France. So this tariff is competed by premiums. One of them can be negative, especially to ferment farm inputs. There is a premium, probably one of the most difficult allowed waste, because there is water, there are bacteria. And if the producer benefits from another subsidies, then the tariff is lowered by €5 per megawatt hour. Okay, you cannot add subsidies from state. What is important to note is that an help for or subsidies from a region like Occitania here is not considered as a public help so far. Well, needless to say that, and it was a question, I guess, in the chat, needless to say that if a supplier pays the feed-in tariff, here 108 euros per megawatt hour for the biomethane, the French government pays back the difference between spot prices and the feed-in tariff. Okay. Today, what we can say in April 2022 is that the biomethane is in the market in France. Last poll. Okay, some key figures maybe. I saw that Tristan gave some figures in the chat. You can read them. Some to be quick, maybe some key figures. Past year in 2021, 4.5 terawatt hour were injected. That represents around 1% of the French national gas consumption. In deeper details, if we look day by day, this injection can reach a higher rate around 8%, when of course the consumption are low, and we expect to reach a rate of around 10% next year. And to end my my presentation, let's take a look at the map where all the the plants connected to the Terega network are represented, the ones that producing right now and the ones that are under construction. This is a good dynamic. Biomethane is everywhere, and we have we can reach the target of almost 22 terawatt hour per year by 2028, which is online with the multi-year planning for energy target. That's all for me.
Thank you so much. So it's done with our members. I wanted to thank all the speakers for the work done to present us respective activities and projects. I noticed some question in the chat, so maybe if you want that we can do it now, Marc, what do you think? Yes?
Yeah, sure.
I noticed the first question in the chat for the first speaker about PRIMA.
Yes, Ramon speaking. I think that I may elaborate a little bit. Perhaps it's a question of Tristan, I think. And let me show, perhaps it's much clearer if I may show what's in pilot plan. Let me, and it's about if I don't know if you may share. It's in the. This is the layout of the one of the pilot plants, that is the hydrogen systems, and I think that well, hydrogen vector has different great advantages, but one of them is that makes easy the coupling of gas and electricity networks, and this, as we mentioned before, different pilot plants are interoperable between them, and hydrogen is an example that okay, we need the electricity produced by the photovoltaic plant, that it's the generation pilot plant, but on the other side we use the hydrogen for income of the bioenergy plant, where we use, for instance, for methanization. So I think that in this hydrogen pilot plant, we are able not only to test the different and the combination between test bench and demos, we also able to for instance, to validate in a sandbox perspective of flexibility or capacity services for the electricity network. And this is an example on how to coupling gas and electricity networks. But Tristan, if you want, we may keep in touch and try to go more in deep or elaborate more in these figures. This electrolyzer here, it's a big bigger that what you propose in Solidia platform, that if not remember, but Sébastien said 10 normal meter cubics by hour, and in this case is a bit higher because we also have a hydrogen station for heavy and light vehicles. So this is the reason that we have well, a mid-size electrolyzer here. Okay, I don't know if I think that it's emaugh because we have not a lot of time.
Thank you. It's very interesting. I sent you my email and mobile phone.
Great.
I think this is something we will do it with all of the speakers. We will share the presentation of each one with contacts. So I will just ask for speakers if they didn't put their contacts, if they can just add it, and then we will share it with all the speakers. It will be easier to exchange. There is several questions from Luis Bertrand. So I don't know if they answer it. He's not here anymore.
Oh yes, Sonia, sorry for that. Yes, between Lionel have been explained very well the feeding in tariff and how is the mismatch on the subsidy if the market is rising. And I understand that at the current prices, the biomethane is competitive without the subsidies now. Okay, thank you.
Absolutely. So far, let's see in the close future.
Yeah.
Okay, super. I think it's done with the questions. Maybe if there is another question, just put your hand up and we can answer it. But if not, we can just say thank you for everyone. Maybe it's time to finish this this meeting, this interesting meeting. Thank you for the CBC for organizing this event, and thank you for all the speakers and participants. And see you soon, maybe. Hopefully.
Okay, thank you so much.
Gracias.
Thank you very much, and we
Thank you
keep
very
in
much,
touch.
everyone.
Yes.
Thank you very much.
Thank
Bye-bye.
you.
Have a nice day.
See you.
Bye-bye.
Bye.